The last few class periods, we have gone over Lewis dot structures for ionic compounds. In an ionic compound, the metal loses electrons, the nonmetal gains electrons. And they are held together by opposite charges. Recall that a covalent compound is different, where if I have a positive nucleus and I have my rings of electrons, a neighboring atom with its positive nucleus could have an overlap. That overlap is where electrons can now be attracted to both nuclei, and it creates what's called a covalent bond. Now, we are going to start to learn how to draw Lewis dot structures for covalent compounds. We're not going to do it in this method. There's going to be a different way that we're going to go about doing it, and that's what I want to show you today. There's a lot of reasons why we go over Lewis dot structures for covalent compounds, but in Chem 1, I think the ultimate reason is to demonstrate that octet rule, that rule of stability. In an ionic compound, metals lose electrons to get to the octet, nonmetals gain. In a covalent, they have to share to get to the octet. So if we're looking at that sheet titled Valence Electrons and Lewis dot structures covalent, step number 1, we're going to draw the covalent bond between hydrogen and chlorine. We need to draw out hydrogen and chlorine. Recall, Lewis dot structures only deal with the outer or valence electrons. Hydrogen has one outer electron. Chlorine, being a halogen, is in the 7th column of the periodic table, if we ignore the D block. Chlorine has 7 electrons that are outer shell. So here's my step number 1. Know what you're starting with. Now, in the past, what we would do then is we would show hydrogen giving its electron to chlorine. That works out pretty well for chlorine. Chlorine is 1 electron shy of the octet. Great. But that doesn't work out well for hydrogen. Hydrogen is a nonmetal. And hydrogen doesn't want to lose an electron, it wants to gain an electron. If hydrogen, with its 1 electron, gains 1 more, it's now like helium, a noble gas. It has a full outer shell. It is stable. So we have 2 things that both want to gain. Chlorine sure isn't going to give its electron to hydrogen, and hydrogen isn't going to give its to chlorine. So instead, they share. There's 2 different ways we could show that sharing. Step number 2 on this worksheet says circle the unpaired electrons. Notice how chlorine has a pair of electrons on the top, a pair of electrons on the right, a pair of electrons on the bottom. But this on the left is an unpaired electron. Now it's paired up. Some people, instead of circling the 2 electrons that are going to create that covalent bond, instead just like to play connect the dots. So instead of circling, some people would just draw a line to connect the 2. Speakers on my phone. To redraw our final answer, we draw a line. That line represents the 2 electrons, 1 from hydrogen, 1 from chlorine, that are now in a covalent bond. Here's my Cl. And let's not forget the fact that chlorine had 6 other electrons around it. Again, our goal in Lewis dot is to demonstrate how things get to the octet. For now, that's the goal. There's other applications that we'll be using later on. So this is the Lewis dot structure for HCl. If I kind of cover up the hydrogen right now, and you look at the chlorine, chlorine has 8 electrons directly around it. 2 on the top, 2 on the right, 2 on the bottom, and 2 from this bond on the left. 2, 4, 6, 8. If I cover up the chlorine, hydrogen has 2 electrons directly around it. The 2 from the bond. And remember, hydrogen with 2 electrons is like helium. It's a noble gas. It's stable as well. What I would like you to do is there's 4 problems on the bottom of the sheet. Why don't you take a few minutes right now to see if you can do this, and then from there, we'll go over the answers together. Right. I'm going to show you the answers to the 4 on the bottom. Bromine started with 7 valence electrons, so it's going to do a single bond here with another bromine. Again, some of you, when you're doing this, you're going to have circles or lines that are kind of curved and crazy and all over the place. We would ask that your final answer be a little bit tightened up, a little bit nicer. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Notice how there's a lone electron on the left and on the bottom. Those will create a bond with hydrogen. Now, if instead you had like the hydrogens going to the right and the left and your pairs of electrons on the top and the bottom, that looks good too. Although some of you are almost bringing your 2 bonds together at one point, and I would avoid that because then you're kind of implying that there's 1 electron making 2 different bonds, and that can't happen. So that's water, Lewis dot right there. CH4. Carbon has 4 valence electrons, 4 hydrogens. It works pretty well. This CH4, by the way, is what comes out of our natural gas jets when we light our Bunsen burners. It is natural gas, so a lot of your furnaces probably run off of it as well. C3H8 is actually what's in your grills if you don't do charcoal grilling, instead you do propane, because that's the formula for propane. Now, you guys could name it as tricarbon octahydride as well, but there are other naming rules for types of compounds too. Those of you who didn't get to C3H8 or thrown off by it a little bit, what I would tell you is that hydrogen only has 1 electron. And if you have only 1 electron, you can only make 1 bond. Never put hydrogen in the middle of things, because things in the middle can get bonded to the left, bonded to the right, top or bottom. Not hydrogen. Hydrogen can only bond once. So what I would have started off this problem doing is here's 1 carbon, here's a 2nd carbon, here's a 3rd carbon. I would start by bonding the carbons together. We'd call that kind of like a carbon chain. So I'll connect the dots here. There's a bond. And there's a bond. Notice how many electrons are left over. 1, 2, 3, 4, 5, 6, 7, 8. How many hydrogens are in the formula? 8. Works out pretty well that there's just going to be a bond to each hydrogen, and it's 1 electron. So this is the structure of the molecule that when you set it on fire, it helps cook your food. Unless if you want your steak blue. Bobby, do you know what a blue steak is? It means they don't really cook it at all. You go to some steak places, you can order like well, medium, rare. I usually go medium rare. After rare, less than that is red, where they cook it a little bit but not much. And blue is even less than that. With your birthday, I don't know if you're going to be going out for a steak dinner or anything, so I thought I'd bring that up to you.